Kia ora, Year 11 and 12. This is the last part of question 3 in last year's algebra exam. So questions C and E are both excellence questions, and D is a merit question. This is the first one. This is question C. And we're asked to find the values for K for which this expression is always greater than 0. Now, the first thing that is always a good idea to do with any algebra problem is to think about whether we can draw a good graph. And here we can. This expression is drawing a parabola. Now, if K is positive, then it's an up the right way parabola, and it'll look something like this. So that's one situation where we're going to have this expression being greater than 0. Some of you are probably thinking, why is she going so slowly through this? But it's because I want you to have a really good understanding of how the discriminant stuff that we've learned links in with this. Now, no one told me that K has to be positive, so let's try making K negative. And you'll see why that's not going to work, and that's going to help me with the algebra. So if K is negative, then this is an upside down parabola. Let's see if we can draw an upside down parabola that's always positive. So if I draw down here, that's always negative. If I draw it here, that's got positive and negative. And if I try drawing it up here, eventually it's going to become negative. So what we should be able to satisfy ourselves of, pretty loosely, is that K has got to be positive. That's going to help when I get to the end of the problem. So for now, what I can see here is if it's always greater than 0, that means that it's got no real roots, which means that the discriminant must be negative. So kx squared minus 12x plus 5k, always greater than 0, is equivalent to b squared minus 4ac being strictly negative. So A is k, B is negative 12, and C is 5k. That gives me the following condition. B squared minus 4ac is equal to negative 12 squared minus k, 4 times k times 5k. And that's got to be negative, giving me 144 minus 20k squared is strictly negative. So I'm going to go through from there on the next slide. Right, we've got 144 minus 20k squared is negative, which gives me 144 less than 20k squared, or 7.2 is less than k squared. I think about that more easily as k squared is bigger than 7.2. If I draw my number line, algebraically there are going to be two regions that satisfy that equation. One is for a positive value of k, and we'll round it to about 2.68, so k greater than 2.68, or k less than negative 2.68. But we know that k must be 0 because we want to have a parabola up the right way. Since k is greater than 0, the only solution region is k strictly greater than 2.68. Okay, so that's the first one done. Not too bad. As usual, you've got to be really confident with how the discriminant works. Okay, and there's another discriminant question earlier in question 3. Okay, so this is the next one, a little algebraic fraction problem. The key thing to note here is that we can simplify quite a bit before we start here, so especially focusing on the denominators. So the only thing I don't know what's going wrong today with is my stylus is doing weird things. So let's write it out with some factorising. Let's first write it out how it is. Always a good way to start. Now we're going to simplify, factorise the denominator in each expression before we do anything else. So here we get 9 over x plus 3, x minus 3, plus 3 over 2 times x plus 3. Now, the lowest common multiple of these two things is going to be 2 times x plus 3 times x minus 3. So that means that all I have to do with this 9 is to multiply it by 2, and that becomes 18. Here, What happened to the 2 times x plus 3? Well, it got multiplied by this bit here, just the x minus 3. So that's all I have to do to the 3. Now, if you're not comfortable with this, there is some really, really good education perfect work on algebraic fractions. If you go back to the level 1 algebraic fractions work, go have a wee look at that. So I get 18 plus 3x minus 9, and that gives me 9 plus 3x over 2 times x plus 3, x minus 3. So I'm just going to use the space up here to finish that off. Now I can factorise the numerator, and I get 3 times 3 plus x over 2 times x plus 3 times x minus 3. And that simplifies to give me 3 over 2 times x minus 3. There are a couple of things I've got to watch out for, though. There are 2 values of x that cannot be true because I can't divide by 0, and they are x is not equal to 3 and x is not equal to negative 3. Okay, so that's a nice little merit question. Make sure you do lots of practice at algebraic fractions because they come up all over the place and they're really useful. This is the last part. This is another excellence problem. And there are several ways to do this one. So we've got to find the values of m for which this equation has got exactly one solution. Now you could use logs to do this, but you don't need to if you spot that 8 is equal to 2 cubed. Okay, so we're looking for the values of m for which this equation has got exactly one solution. So let's rewrite it like this. Okay, now just I've got the same base now, so I can just equate the powers. I've got m times x minus 3 is equal to 3x squared, and that's a quadratic. So what I'm asking is, when is there exactly one solution to that? So this comes back to the idea of the discriminant again. We can write this as 3x squared minus mx plus 3 is equal to 0. I'll just do it on over here. Whoops. Sorry about that, guys. Okay, here we are. For one solution, you must communicate your thinking clearly with this. For one solution, what do we need? Well, we need b squared minus 4ac strictly equal to 0. And our quadratic that we'd got down to was 3x squared minus mx plus 3 is equal to 0. b squared minus 4ac is equal to negative m squared minus 4 times 3 times 3, and that has to equal 0. So m squared minus 36 is 0, so m can be either 6 or negative 6. So let's just check that that works. We've got 2 to the power of mx minus 3 equals 2 to the power of 3x squared. And so then there's no restriction at all on having negative values of m. That's fine. So that'll be my final answer. All right, thanks for watching. I'll do the 2 easier questions in question 3 later on, and you can watch those then.